This conference will now be recorded.
Good evening, students. Today we are starting with new chapter, that is ray optics. So in this chapter we'll be learning reflection of light, basically spherical surfaces, spherical mirrors, spherical lenses will be discussing in this chapter, and also we'll learn the combination of lenses, etc. So let us start with today's discussion. So today we will be particularly discussing what is called light, what is a ray or beam of light, what is this ray optics, what are the laws of reflection. This you might have already learned, but we'll just recap. But the spherical mirror we'll discuss in detail. Various terminologies which are related to spherical mirror will be discussed, and sign convention will be discussing today. Okay. All right. So let us start our discussions. So what is light? We have already learned electromagnetic wave, spectrum of electromagnetic wave. So light is a part of electromagnetic spectrum, and that part which has wavelength ranging from 400 nanometer to around 750 nanometer. So this particular range of electromagnetic spectrum is called light. This provides the sensations of visibility, or this helps us to see the world around us. Okay, so this provides sense of visibility. Okay, provides visibility. Visibility. Okay, and what more about light? It has speed in vacuum. You know that 3 into 10 to the power 8 meter per second. This is the high speed attained so far. So far, this speed of light is the highest speed attainable in the nature. Nothing can go faster than light so far. So far, it is the highest speed. Okay, so this is about light. And you know what is optics? Optics is a branch of physics or engineering. Optics is a branch of physics or engineering where the production or the source nature and application of various properties of light, various properties of light are being studied. I'll give you some example, right? So what is the production? Production of the source of light. Nature of light, it can reflect, it can refract, and then many other. It can diffract. So diffraction, reflection, refraction, polarization, these are the various properties of light, and how we can apply all those nature or all those properties of light or phenomenon of light in our life to have a decent applications of those properties. Okay, so that branch of physics is called actually uh, optics. Okay, now optics, this can be again subdivided into two. One is ray optics, ray optics, optics. Another one is wave optics. Okay, I'll tell you what these are, but obviously today we are learning or we are starting ray optics. Later we'll learn what is wave optics. I'll tell you briefly what is ray optics and what is uh, wave optics. So let me tell you first about wave optics. Actually, some natural phenomena with light, like interference, 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 diffraction, diffraction, polarization, etc. These properties could not be explained by the ray concept of light. Okay, or in other words, interference, diffraction, polarization, these properties of light or this phenomena of light can be only explained by the wave theory of light. Okay, wave theory or wave nature of light. So where the branch where we analyze these properties, okay, these properties with the wave theory or wave concept of light. Okay, here we use wave concept of light, concept of light. Light is a wave. Okay, so we have already seen, so those wave concept of light. Obviously light can be acting as a particle, acting particles also. So here in the ray optics, actually we'll take up two properties. One is actually so ray optics actually is developed on two basic idea. One is the uh, corpuscular model or the particle model, particle nature of light. I should not say particle nature, particle concept or corpuscular concept of light, which was actually further developed by Sir Isaac Newton. And then laws of reflection. This ray optics actually developed based on corpuscular nature of light and laws of reflection, refraction, etc. I think I have written that down. I'll just show you here. So there are two branches of optics mainly. One is, now again you will learn in the higher classes, there is something called non-linear optics as well. So ray optics, wave optics are the main subdivisions. Okay, so ray optics, what is ray optics or geometrical optics? So ray optics is concerned with the particle nature of light or corpuscular nature of light, and it is developed based on the rectilinear propagation. Okay, rectilinear propagation of light and laws of reflection and refraction. So these two things are there. Okay, ray optics or geometrical optics also, it is called geometrical optics because we'll see whole lot of geometrical idea or geometrical considerations we have to make while reading or studying this branch of physics. Okay, this branch of optics. So that's why it is called geometrical optics as well. So this geometrical or ray optics actually is developed based on two basic concept. One is rectilinear propagation of, or two basic aspects of light. One is rectilinear propagation of light, and another one is laws of reflections and refractions. Okay, now, okay, so this again I have written. All right, now as we are saying that we are going to learn ray optics, then we have to understand what is ray. So as we said that rectilinear propagation of light. So this ray optics is actually based on the particle nature or corpuscular nature, and as you know, classical particle, if you just throw it, it will actually move in a straight line, right? So if we just think that light is actually composed of some particles, okay, then while propagating, it will propagate in a straight line, okay, along a straight line. So that is actually called rectilinear propagation aspect of light. And the path along which the light travels, the path along which the light travels is called the ray of light. So this is the path of light, path of light, path of light. So the path through which or along which the light travels, that is called actually path of light or ray of light. This is path of light or ray of light. And a bundle of ray of light is called beam. This is beam. A bundle of such rays. Such rays. A bundle of such rays are called rays. Is called beam. A bundle, or yes, so a bundle of such rays is called a beam of light. Okay, so ray of light, beam of light we have learned. Now we'll learn what is reflection. Reflection, you know, right? If, say, if a ray of light, if a ray of light uh, is undergoing reflection, it will just go to the same medium from which it has come. Okay, that means what? Suppose this is air, this is the mirror, as you see. This is air. Light ray has come through the air to the mirror, and again it is coming back to the mirror itself. So this is reflection. Okay, so if a ray upon striking a surface goes to the same medium from where it has come, actually that incident, to be very simple, so that that phenomena is called actually reflection. Okay, so reflection you can actually realize from mirror. Okay, so because of reflection we see our face, we can see our face because of reflection of light, which is going from our face to the mirror, and that comes back, and when we see those reflected rays we can see our body or our face, etc. So this is law. So this is actually reflection. And what are the laws of reflection? There are two laws actually, you can see. So before I state the laws, I'll just tell you what are these. So this is a mirror. This is the ray which is actually coming upon or falling on the surface of the mirror, reflecting surface of the mirror. So this particular ray is called incident ray. So the ray which is actually falling on the, or coming to fall on the mirror, surface of the mirror, and the ray which actually is going away from the surface of the mirror after reflection is called reflected ray. Okay, and see there are these angles. So the angle, and this is the normal to the surface of reflecting surface. Okay, normal is drawn on the reflecting surface. Okay, and you can see the angle between the incident ray and the normal is called angle of incidence. So this angle is actually called angle of incidence. Angle, I think you know this. Just to recap, incidence. Okay, and the angle between the reflected ray and normal is called the angle of refraction. Okay, angle of refraction. Okay, angle of refraction. All right, now let me tell you the laws of reflection. You have been studying this since your 8th standard. So angle of incidence. Okay, angle of incidence. Generally, angle of incidence is denoted by I. Angle of incidence is equal to angle of refraction if they are same. Actually, sorry, reflection. Angle of incidence and angle of reflections are always equal to each other. Angle of incidence and angle of reflection will be always equal to each other. Okay, if this is theta incidence, if this angle is 30 degree or 60 degree, then this angle of reflection also will be 60 degree. Okay, the second law is that the incident ray, reflected ray, and normal to the surface, reflecting surface at the point of incidence will be in a plane. See, these are in a plane. So incident ray, normal to the surface, normal to the reflecting surface, and reflected ray are in plane, in the same plane, Okay, so these are two laws. Okay, these are two laws of reflection. Now these laws are actually valid everywhere, even in the curved surface also. So these laws, I just want to make one comment here. These laws of reflection these laws of reflection are valid for any arbitrary surfaces, not only for plane surface, any arbitrary surface. Surfaces, even they act or they are valid even at the curved surface. Okay, even at the curved surface, these laws of reflections are valid. Now we'll go to the next topic, that is spherical mirror. So what is a spherical mirror? Spherical mirror, as the name says, it is not actually spherical. It is not actually by shape, it is spherical. It is the mirror, or it is a surface. It is a reflecting surface which is a part of some hollow sphere. That's why it is actually called spherical mirror. So spherical mirror is a part of a sphere. That's why it is called spherical mirror. So a spherical mirror is a reflecting surface which is a part of a hollow sphere. See here in the figure A, this is a hollow sphere. Okay, in the figure A, you can see this is a hollow sphere, and suppose this is a plane just passing through the hollow sphere, so that it can cut a portion like here as shown in the B. So if we cut a part of a hollow sphere, that will act as a spherical mirror or spherical surface. That is actually spherical surface. But if you silver the either surface, okay, either of the surfaces, then it will act as a mirror. Suppose, see, I can have a portion like this, right? Now if I silver, or if I just cover the inner surface, okay, or if I polish the inner surface with silver, then it will act as actually, so this side will be reflecting surface, and this polished surface will not be reflecting. So this will be called, this B is actually called, this is convex. You can see the bulge portion, bulge outer side. This is, so this particular surface is bulged outside, okay, bulged outside. So if the bulge outside is acting as a reflecting surface, then it is called convex mirror. Convex mirror. If the bulge portion of the spherical surface is polished with silver, and the inner part of that particular surface is acting as a reflecting surface, then it is called actually uh, a concave surface. Concave sphere. Concave sphere. Okay, so you have understood what is a spherical mirror, what is called convex mirror, what is called concave mirror. So if the bulge portion is not polished, then it is called convex surface. If the bulge portion is silver, then it is called concave surface or concave mirror. Now we'll see, here you have been given a concave mirror or concave spherical surface. You can see this is the reflecting surface, this is the silver surface. So light rays from here you cannot get reflection, but the spherical surface will be always reflecting from the inner. Concave surface will be always uh, so the inner surface is reflecting surface here, so it is concave mirror. Okay, concave. Now we will be learning various part of or various terminology which are related to the spherical mirror. First of all, what is called pole? So what is pole? Just geometrical center of the spherical surface or reflecting surface is actually called pole. So this is the geometrical center of this particular APB surface. Okay, APB surface. So geometrical center of the reflecting surface or spherical surface is called pole. So pole is denoted by small capital P. Then we'll see what is radius of curvature. First of all, what is center of curvature? See, center of curvature. So we have learned what is pole. This is actually center or middle of the lens. Oh, sorry, middle of the spherical surface. See, now pole is done. Now we'll learn about center of curvature. Center of curvature. What is center of curvature? As you know that spherical surface or spherical mirror is a part of a bigger sphere, a part of a hollow sphere. So center of curvature is that surface, sorry, is that center of that sphere. The mirror is a part of which, okay. So center of curvature is the center of that particular sphere. Center of that particular sphere. The reflecting surface APB is a part of which, okay, part of which, that is, okay. So we have learned what is called center of curvature. Now what is radius of curvature? Radius of curvature. So radius of curvature is what? It is the radius of that particular sphere. The reflecting surface is a part to or part of that particular sphere, okay, or part of which. We can say the radius of curvature is the radius of that sphere. The reflecting surface is related to or is a part of which, okay. What is principal axis? See, this is principal axis. It is already denoted here. So the principal axis is the line joining the pole and center of curvature, and if that line is extended on either side, that is called actually principal axis. So what is principal axis? Principal axis is the line joining the pole and the center of curvature of the mirror is called the radius of curvature. Up to here we will say radius of curvature. From the center of, so this is actually, see, up to here, I'm sorry, this is center of curvature to this, so this is actually radius of curvature. PC is the radius of curvature, okay. PC is the radius of curvature. So what are the terms we have so far learned? Pole, geometrical center, then we have learned center of curvature, that is the center of the sphere itself, and we have learned what? Center of curvature, then radius of curvature, then we have learned principal axis, Now we'll learn what is there are a few more terms to learn. One is focus, another one is focus, and so principal focus, etc. and 2f distance we will learn again here. Then we'll learn about angular aperture, linear aperture, etc. So first let us see what is called or what are called focus. So focus is actually a point on the principal axis. See, I'll just tell you for the previous cases also. Center of curvature is denoted by S, pole is denoted by P. Okay, now we are going to learn focus. Focus is always, so focus is a point on the principal axis. Point on the principal axis when a parallel rays are getting reflected by a spherical mirror, they will converge or they will pass through a point on the principal axis. That particular point is called focus. Okay, so focus is a point on the principal axis through which the parallel rays pass after reflection. In case of, this is in case of concave mirror. So in case of concave mirror, we can define the focal length as the point on the principal axis. After reflection from the spherical mirror, the parallel rays pass through that particular point. Okay, and so principal focus, this is actually called principal focus. So the principal focus is the point on the principal axis, either side of the principal axis also, you can say either side of the, in case of, actually in case of mirror it is here. So it is the point on the principal axis through which a parallel beam or the parallel beam of light pass after reflection. That is in case of concave mirror. Or it is the point in case of convex mirror, we can define the principal focus as the point on the principal axis from which the reflected rays, okay, parallel rays after reflection appear to come out. Okay, so how we can say? We can say that in case of convex mirror, principal focus is the point on the principal axis from which a parallel beam of light after reflection appear to come out or appear to diverge. Okay, that is actually focus. And generally focus is lying in between the pole and the center of curvature. So generally focus is lying on the principal axis and in between the pole and the center of curvature. Yes, center of curvature. What is focal plane? So focal plane is the plane which is passing through the focal point, okay, focal point, or the passing through the focus, and it is perpendicular to the principal axis. Okay, see, you can see this is the focal plane shown here. So this is the plane which is perpendicular to the principal axis and passing through the focus. You know, this principal focus has a length. Okay, if I just, so PF, this length is denoted by small f. This is called focal length. Focal length. It is called focal length. In both cases, PF is the focal length, and the CP or PC, that is actually radius of curvature. Radius of curvature. See, parallel beam, when parallel beam gets reflected from the mirror, they either converge to a point on the principal axis, or they may appear to diverge from that a particular point on the principal axis, which is actually focus. So parallel beam after reflection either will converge on the focus or appear to diverge from that particular focus. Okay, but when the rays are not parallel to the principal axis, see, parallel rays means rays which are parallel to principal axis are called parallel rays. So these are actually parallel rays. Parallel rays. Okay, and these are actually called oblique rays. These are oblique rays which are not, sorry, which are not parallel to the principal axis are called oblique rays. Oblique rays. So when these rays are parallel to each other, but they are oblique to the principal axis, so such rays after reflection will pass through the or meet on the principal on the focal plane. Okay, principal focal plane or focal plane. So we see the parallel rays after reflection they meet or they appear to diverge from the focal point, but oblique rays, oblique in the sense the rays are parallel to each other, but they are not parallel to principal axis. After reflection they will meet in the focal plane. So that is the fundamental idea about this, and we will see that this focal length is exactly half of the radius of curvature. Okay, half of the length of the radius of curvature. Okay, or R can be written as 2f. This will prove sometime. Okay, this will prove sometime, but today we'll discuss few more terms. One among them is linear aperture and angular aperture. So these are actually very, very important terms, linear and angular aperture. So if I show you here, this is the spherical mirror or the reflecting surface, spherical surface. So I'll just draw here for you. Sorry. Suppose this is a part of spherical mirror. I should not. Okay, let it be taken like this. Okay, this is spherical mirror. If I draw this principal axis and see, this is actually this length. Okay, see this AB, this is P, this is the pole, and this is center of curvature, say, and this is focus somewhere here, and this is AB, this linear distance. Okay, or it is the diameter of AB, sorry, diameter AB of the circular boundary of the spherical mirror. Okay, or you can say if we just connect the end part or ends of the spherical surface, the line we get is called actually linear aperture. This is called linear aperture. Okay, this is linear aperture, or it is actually the diameter of the circular boundary, circular boundary of the spherical mirror. Okay, it is the diameter of the circular boundary of the spherical mirror. Linear aperture. What is the angular aperture? The angle made by the ends of the spherical mirror at the center of curvature. This is actually called angular aperture. So this is angular aperture. Okay. So what is angular aperture? See, the ACB angle. ACB angle is called the angular aperture. It is the angle subtended by the boundary of the spherical mirror. Okay, this is actually angular aperture. Angular aperture. It is the angle subtended by the boundary of the spherical mirror. Spherical mirror at the center of curvature is called angular aperture. So we have learned linear aperture, which is the diameter of the circular boundary of the spherical mirror. So this is polished surface, so it is a concave one. Okay, and angular aperture is the angle subtended by the boundary of the spherical mirror at the center of curvature is called linear aperture. These are the parameters which are important. Okay, or one more point I just want to say, the rays which are very near to the principal axis are called paraxial rays. Okay, or sometimes the paraxial approximation. So paraxial rays, the rays which are very near to the principal axis are called paraxial rays. Okay, all right, then we'll just conclude our session by understanding the sign convention of the spherical mirror. So just to understand this sign convention, you can just think of, see, this is my pole, right? So I can just think that this is axis system. This is y, positive y, this is negative y, and this is positive x, and this is negative x, and pole is exactly at the origin. Okay, now the distances we measure right of the pole. Okay, right side of the pole will be always positive, or in the upward direction from the pole is called our principal axis. Okay, upward directions from the principal axis are all positive. Like in this case, this height is positive, but this height is negative because it is down the or in the downward direction. See this direction, if I take any distance, like say this one, this is negative distance, okay? Whereas this distance is positive. This is positive distance, and this distance we measure just opposite to the, or in the, like in the left side of the origin. See, origin is at P pole, so that's why this side will be strictly taking negative. Okay, or in other words, you know that the distance we measure. So positive will be the distance we measure in the direction of light or direction of propagation of light. So distances measured along the direction of propagation of light. Propagation of light are positive always. Positive always. Okay, the distances measured in the opposite direction, that means measured in the direction opposite to the propagation of light, is are actually always negative direction. Okay, and height, if we measure below the principal axis, are negative, and height measured above the principal axis will be positive. So this is simple, very simple. We'll just apply these sign conventions while solving numerical problems. Okay, so we'll stop it here for today. In the next class, we'll be discussing about reflection from the spherical mirror. Okay, and various problems will be picking up from examples or from various previous year's papers. Okay, so thank you for your patience. Bye for today.